Hello everyone, so I will talk about the different types of metallic crystal structures. The atomic bonding in this group of materials is metallic and thus non-directional in nature. Consequently, there are minimal restrictions as to the number and position of nearest neighbor atoms. This leads to relatively large numbers of nearest neighbors and dense atomic packings for most metallic crystal structures. Also, for metals, using the hard sphere model for the crystal structure, each sphere represents an ion core. Three relatively simple crystal structures are found for most of the common metals: face-centered cubic, body-centered cubic, and hexag-cubic, and hexagonal close-packed. First type is the face-centered cubic crystal structure. The crystal structure found for many metals has a unit cell of cubic geometry, with atoms located at each of the corners and the centers of all the cube faces. It is aptly called the face-centered cubic (FCC) crystal structure. Some of the familiar metals having this crystal structure are copper, aluminum, silver, and gold. The figure shows a hard sphere model for the FCC unit cell, whereas the atom centers are represented by small circles to provide a better perspective of atom positions. The aggregate of atoms in this figure represents a section of crystal consisting of many FCC unit cells. These spheres or ion cores touch one another across a face diagonal. The cube edge length and the atomic radius are related by this relation. Crystal structure: each corner atom is shared among 8 unit cells, whereas a face-centered atom belongs to only 2. Therefore, 1/8 of each of the 8 corner atoms and 1/2 of each of the 6 face atoms, or a total of 4 whole atoms, may be assigned to a given unit cell. This is depicted in figure where only sphere portions are represented within the confines of the cube. The cell comprises the volume of the cube, which is generated from the centers of the corner atoms as shown in the figure. Corner and face positions are really equivalent. So, now coordination number of FCC structure. For metals, each atom has the same number of nearest neighbor or touching atoms, which is the coordination number. For face-centered cubics, the coordination number is 12. This may be confirmed by examination of this figure. The front face atom has 4 corner nearest neighbor atoms surrounding it, 4 face atoms that are in contact from behind, and 4 other equivalent face atoms residing in the next unit cell to the front. Finally, we differ by the atomic packing factor APF. The APF is the sum of the sphere volumes of all atoms within a unit cell, assuming the atomic hard